Today's plan is to basically review, finalize any issues with Chapter 4 FDD assignment, the case study, and get into DFD, data flow diagrams. I find the more enjoyable part of actually almost graphically programming, laying out a system design. But first, who would like to pray? Thank you. Time of the IBM, and you walk through, you see all these little devices hanging from the ceiling, like every 30 feet, and you finally wonder, what is that? Some kind of temperature sensor? And no, they're little speakers that just are generating white noise. And if you stop and listen, you hear kind of a, and it mutes the conversations between cubicles because it's all open cubicle. Looking over Chapter 4 as we leave that behind, a few things came to mind as I was going over what we've done. Think about your customer and laying out the system requirements. It's easy to, you kind of just make a list of things, but don't be afraid to revisit the list of items on that requirements list and review that with your customer. And remember, who's that commentary the other day? Where was my little notes about that? Maybe I saved them already. But the commentary about that this guy gave was when you define your scope, if you have a limited scope, it can sound adversarial, like this is only what you're getting, and have it very, very cut and dried, tends to actually put people at odds with each other. So with your system requirements, review that in a friendly way of, hey, we want to make sure we have a list of what you've agreed on. Make sure that there's nothing missing, and one way to help ensure that there's nothing missing, because here's an example of a system we did for the cafeteria, and actually some programmers attempted the system, and we actually had a system running for I think 4 years using a system built by a student that had already had some background in programming. But we'd go to the cafeteria director, and they'd say, I need a system to handle students swiping in. And we'd say, well, what do you want? Well, they'd kind of have a general idea, and then they'd say, well, show me what you can do. And it's like, well, do you want this? I don't know. Yeah, I guess I want that. And, well, do you need this? Yeah. And what do you want your report to look like? I don't know, show me something, and it'll probably be okay. So what we needed to do quite a bit is actually generate some prototypes, even while we were discussing what they needed. It's easy to do a quick prototype in PowerPoint, and even better, it's easy to do a quick kind of a functional prototype in Visual Basic, because it's easy to build up a GUI interface. The actual code didn't work, but you could show, if I click on this, this is what will pop up. If I click here, this would do this for me. Is this what you want? And as people look at prototypes, they start to think, okay, now yeah, when I do this, here's what I need to happen. Then suddenly the ideas start popping in their mind. So when you're talking about requirements, remember as you do prototypes, make it clear to them, hey, this is just laying out what the screen might look like. Is this what you need? And as they finally come to, hey, yes, this is really what we need, make sure you delete those extra things that were not mentioned as something that was really needed, and maybe put them on a separate screen of, here's future possibilities, but not part of this project. And regarding the strict rule about the scope, make it clear that if they do ask for other things, that it will take a little bit more time, but maybe not make it a strict, hey, I can't ever do that. We're not being paid for that. Make it a, well, that would take some more extra work. Is that what you really want? And advisory kind of way rather than a, nope, you're not getting that. You didn't pay for that. Let the administration people negotiate those things, and deal with your boss saying, hey, this is what we've clearly said as our goals. So make that clear. We're going to come now to the DFD. This is our kind of, you can almost think of it as graphical design, but it's more of a modeling of our of system activity. And specifically regarding system activity, the data flow through our system. Thinking about the data flow starts giving us some ideas of, okay, how are we going to actually make this work? So let's bring up the book and the discussion of the, is it 4? I think there's 4 objects in the data flow diagram rules. And where is my book? I'll pop up my book page here. Chapter 5. System analysis phase, data and process modeling. So we're starting right here in the symbols and data flow and drawing a data flow diagram. They start from the general to specific. First of all, they kind of review the concepts of why we're doing data flow, and we jump to our data flow diagram symbols. Here's our symbols that we're going to use to draw and explain, kind of explain and plan out, analyze how we're going to, how data is going to flow through a system as we think of, okay, how we can meet those system requirements. So 4 basic shapes. There's 2 different modeling symbols being used. They're very popular Jordan symbols. This book uses the Gain and Sarsen symbols. These are fairly commonly known out there. Don't confuse this, as I often do, with UML diagramming. We're going to get into that. It looks similar. It's actually diagramming relationships between modules in your code. Now, an easy way to model these, I like using PowerPoint. Visio is available, but it's kind of a pain. You have to go install Visio. You are welcome if you'd like to try using Visio for this. I'm just going to use PowerPoint because I find it pretty easy to lay out these symbols. So I'm going to bring up PowerPoint and draw these symbols and then discuss them as we learn how they work. But we'll start with the big pictures. And do I have PowerPoint running somewhere? I'm not sure I do. Let me get PowerPoint up here. Oh, there I have a window somewhere. Okay. I'll start with a blank PowerPoint, although you could have a theme and have really impressive So make a PowerPoint and start your symbols. And I'm just going to use a blank page to bring some symbols in. It's just simple little shapes. The first one is a rounded rectangle. And this represents a process. Where'd my book go? There. This represents a process. The rounded rectangle. The little line at the top just is a little box to delineate the title of my process, and then the verb for what the process does. So an easy way to make that to be nameable is I can come over here and draw me a text box within that. That's going to be the process name. So I'll call that the process X. And I'll draw a little line across. Can't see the line. I will give it a, and we'll apply a quick style to that big shape. That doesn't look too bad. Maybe I'll give it a black outline. And I will now also draw another text box within that to hold the description of that process. And one thing I like to do is I draw little invisible shapes along the edge for connectors to that. Oops. Put it right on the edge. And bring another one over to this side. And another one over here. They're invisible little boxes, and I'll show you the usefulness of them. Now we'll take this whole thing and group it. And I can even add more little edge parts there. Where's my grouping? Now, as I connect processes using connectors, and I think the general form is arrowed connectors, straight lines, I can now connect to different parts of my object, and I think those little individual, oh, I guess those little text boxes that are hiding in there can act as little connector holders. So now that I thought that was going to hold on to that. Try that again. Underneath shapes, the line section. They're called connectors. Yeah, you can do that in Visio as well. And let's see now. Okay, now if I connect it just right, see how it follows my line? The reason those little boxes are there, normally if I just have a rounded rectangle, I can only connect to the one edge. But now with those extra little pieces in there, I can connect to multiple places where a little dot shows up. And rather than having them all merge into one input spot, they follow the multiple connections. So it's easy enough to add more. As long as when I'm putting in a connector, I find those little dots as they show up as I hover over them, I'll be able to connect to multiple places. Oh, and I remember I only happen to add the one extra text box on this side. These have a few more because I add the little invisible text box. So allowing the multiple inputs and outputs into my process. So this is the process symbol. And Visio has connectors as well, and when you have multiple things, you can rearrange them. So the software that allows you to do this kind of thing, having the connectors movable is very handy. Now I think I'd like to put a title. We want to put titles on our lines in between, because the next symbol between processes, this is probably the most critical part of our data flow diagram, is naming the data that's flowing between processes or data stores or external entities. So this is the key for things that happen in our system. We name processes, and eventually these processes that are being named will become actually software modules, could become functions within our system, within our software. If it's a machine, a physical machine, this will become one mechanical part of the machine, like think of a car engine. You might think of this as the carburetor, and the data in you can kind of think of as the fuel mixture coming in. And the carburetor applies a mixture, and out from the carburetor into the engine is the air and fuel mixture. Most of this, though, mainly applies to software data flow. We're not thinking as much as a process and physical materials going between them, although you could make the analogy and make data flow with like a big processing plant. So data flows between processes, from processes to this other symbol called a data store. So far we have, let's go ahead and bring in a text box here. We have process, we have data flow, and now we have data storage. In a system, it's often a database that we send data to, but it could also be storage of variables in memory. They call it a data store, but storage, I'll call it a data store. So we have a data flow and a data store. And there's rules to follow as we work with these. Let's go ahead and make a data store. In Visio you have one there, I think. I'm just going to make one since they're easy enough to make. I'm going to draw a line, multiple, not that. I'm going to draw a shape with straight lines, free form. Yeah, I guess I'll use a free form. Because it's open at one end is one little weird thing about it. I don't see built-in ones here in PowerPoint, but it's easy enough to build your own. I'm going to do a free form shape. Oh yeah, hey, you could do that. Yeah. And I hold down the shift key to make sure it's a horizontal line. And hold down the shift key, make it vertical. And shift key and double click. And I have my open shape. I'm going to make the outline black. And let's see what I have. There I have my data store. It's supposed to look like that, and it's supposed to have a name on it. So I will add another line about here, draw that, make it black, and I'm going to be I want to put names in there, so I'm going to put my little invisible text boxes within that shape. There's going to be room for putting a name, and might as well bring it out to the edge because then it'll let me do those connectors to the edges. Yeah. They're the same. The two sides. This is the Jordan style, and this is the Gain-Sarson style. 4 symbols, very similar looking. Once you pick one, you'll use the same one. So I wouldn't mix circles and rounded rectangles. So I have a text box for putting in the. I think there's going to be numbers in here going with the number. We're going to be assigning numbers to our data stores, and we're going to also put in a description of it. So I'm going to put in a spot for a text box there as well. And now I'm going to adjust my shape here, make it a little longer, and now I'm going to group those together, and that'll become my data store shape, and I'll arrange and group that. So now I can copy paste my data store. Let's see, can I make my shape outline a little thicker? Let's make the outline just a bit thicker. Now I can connect processes to data stores because I have those text boxes in there. It should connect. Look at that, it's not connecting for me. Oh, it's disappointing. I thought I would find my edges of my text boxes that I grouped into there. Oh, just under shapes, there's connectors. Oh, once you hover over it, it should show a little black dot show up. It's not working for my data store. Look at that. I guess it only shows a little dot at the very end of that line. Well, here's what I can do. I can draw a invisible box around it. I'll draw a regular rectangle exactly matching, exactly matching the positions of that, and I'll make it an no fill and no outline, but I will group it with the thing I just drew. Now let's see if my connector will find a spot to connect. Look at that, it's not finding a spot to connect to. That's irritating. I thought I had this working before. So maybe you can't do a freeform. Maybe it doesn't like to connect to freeform objects. Well, we'll just add it there. See, now when I move this, see how the connector doesn't follow it? I wanted it to follow it. Well, we'll work on that. And that's where Visio automatically does that already for you. And it has built-in connectors here for naming. And I do have Visio on this computer, but sometimes you just don't have it. This one here, as I resize it, I think the connectors will follow. I'll have to revisit my data store. Well, anyway, let's go back to my data store and give it a name. Data. Oh, look at that! I thought I put some text boxes in there. Did they not get grouped? Let's try that again here. In shape, text box. Put one right there. This is my data store. Now let's group it. Now let's see if my connector will connect to it. There, now it has a connecting box. Maybe empty text boxes just go away. Except they didn't go away over here. Now I can move my data store around and my connector follows me. So data flow, let's go ahead and give that a name. And connectors don't automatically have names to go with them. In Visio, if you double click on a data flow line, it'll actually bring up a place to put the title. I have to apply a text box next to a connector, and I can group it, and I'll call it data flow. And let's see if I can group that with that connector. Now that I've grouped it, let's see what happens as I move that. Oh, look, that the data flow word doesn't move with the line. I believe in Visio it will move your data label around. So this is where PowerPoint falls down when I want to group a label with a connector. It'd be nice if PowerPoint actually had named or labeled connectors, which it doesn't. So after playing with this for a while, you might give up and say, you know what, I'm going to go spend the time to install Visio and use the Visio data flows. There are online, well, there's open source diagramming tools as well. One called DIA, one called, well, there's some online graphical drawing programs, one called glyphy.com, where you can actually draw these online, pretty slick. And I think in our course page, I do have, where's my course page? I do have some links to software for data flow diagramming. Let me pop that up. Let's see, OpenProj, no, that's the management. Ganter, scheduling, where was our, maybe I put it down here in the modeling. Yeah, here's some of the software. Most of the code, well, a lot of this graphical drawing tools I found online, everyone does UML modeling. There are let's see, I thought I had Gliffy. Gliffy.com has a nice online drawing package, but I couldn't find data flow diagram. Okay, so back to here now. So that we got the first three: process, rounded rectangle, the data flow, the data store, holding data that has been processed and may need to be managed and sent along. And then the last one, easy to draw in PowerPoint, a external entity, or just entity. This can be a person or another system. So back in PowerPoint, I simply can use a shape and apply shadowing to it. So I can apply any quick style to that shape if I use my similar style as the other, and then apply special, where's my shape effects, I can apply a shadow to it. And you can choose how dramatic your shadow is. Something more dramatic than that, I can just do this. I can just copy paste that and fill the one behind it with black to make a manual shadow. So there's a external entity, and I can group that. And you have all this in Visio. So this is my entity. Oh, double click. I have to double click to label my entity. And there's some nice things about using PowerPoint. I have a little more graphical control in PowerPoint than I do in Visio in terms of the look of my font and the colors of things. If you share this with your manager or other people on the project, they may find it easier to adjust things in PowerPoint than learning Visio. If you've got a lot of programmers and people comfortable with learning Visio, that will probably be your tool that you use for diagramming, because it gives you lots of other capabilities. So here's your basic types. Let's make the connectors a little thicker. Let's see here. My data flow, where's my line thickness? There. Make it a little thicker. And make the outline black. So there's my data flow. I have to double click and manually adjust my label, which is kind of annoying. But in other programs, you'll also find that as you move things around, the lines start not cooperating with you unless you put the things in exactly the right place. So the 4 shapes, this was, where's my text box? This was my process, my data flow, my data store, and my entity. Now, simple rules of managing the 4 symbols is that data flow can only go from a process to something else. A process has to be involved in the data flow. So you can't have a data store sending data to another data store. And I think the book gives you a nice little diagramming of our rules of data flow diagramming. And some examples there where a process of creating an invoice takes in data, and notice the data is not always a specific name. It's sometimes kind of abstract. Service is performed, and it creates an invoice, and the data coming out is the actual invoice data. Grading student work, their submitted work is the data flow. As you get into more details, the submitted work will involve files or data types in the file, the output, the graded work, and then the final grade. See how processes always have an input and an output. Data flow, I think the rule is it always has a one arrow, and if you have data going both ways, you name both arrows, even though it may be a very generic term like data in and data out. Processes can communicate data to other processes, but you cannot break these rules. You cannot have a process that is only producing data. This would be a spontaneous generation process where it's creating data from no source of data. This is illegal. This is a black hole of data where you're just sending data in to a process. It never produces any data. And this is a little fuzzier problem where you have data coming in that doesn't match it doesn't provide the information needed to actually produce that final output. That's called a gray hole. So a terminology for each one: a black hole process, spontaneous generation, generating data but not taking data in order to do that. Well, in terms of the proper documenting of data flow, you have to always, a process always needs information in order to produce information. So this is more likely to be incomplete documentation because it's not showing that there is data coming in order for this process to generate this data. Now, external entities, we don't have to worry about what goes on in there. We can just say an external entity produces some data. But for processes, they always take in information and generate information. And we diagram that in our data flow. Okay, so there's our data flow. Our data store holds data for us. And notice data stores always take data or produce data for processes. The same process can take data out of a data store and put data in. It processes invoice and sends payment detail back into a data store that other processes can use. This data store only reads from the patient data store, this process, where this process only writes data to the data store. That's legal. Now, these processes aren't completely diagrammed because there will be other data flow in order for this guy to know what to do for the treatment. So this is just showing the interaction with the data flow. This interaction is correct. These all will be spontaneous generation if this were the only diagram. Now, incorrect use of data flows is where a data flow communicates directly to another data flow. This is not allowed. There's a process that has to pull out the data. Data just don't automatically talk to each other. What's wrong with this one? It has to do with the full diagram will have another arrow coming out or into this data store or to this process. So even though up here they're saying it's correct without data coming in, here it's saying each data store, or actually they're talking about the data store. You can't have only one arrow. The process is, the data store should have an incoming and outgoing data. There has to be some way for the data to get into the data store. So looking strictly at the data store, there should be, just like in processes, shouldn't be black hole or spontaneous generation of a data store. So just like here, you see data comes in, somehow data gets stored there, and another process uses it. This is a write-only data store. We're only putting data in. We're not documenting whether anything ever gets read from that data store. Now, a data store that hardly ever gets read might be something like a system log. And you want to say, yes, we're logging information. To be properly documented, you would add a little arrow out and maybe a process called log monitor. That would make it a proper data flow diagram. Even though the log monitor process may never get called, we do have a reason for saving logs and storing them in a data store, which sometimes uses up a lot of data. Okay, so there's our data store element. And then the much more flexible and treat it like a black box, the external entity. This can be a person, it can be an organization, or it could be representing another process, like the accounting department's accounting system. So external entities interact with our system, and in our data flow diagrams, the whole reason of data flow is to analyze and to model how our system does what it needs to do to perform to meet the system requirements. We don't worry about how external entities communicate with each other. A bank may, a customer may go to the bank and have some interaction. We don't document that because that's not part of our system. So we don't draw lines directly between external entities because they're not part of our system. If there is some interaction between a customer and the bank, we show a process in our system that does that. So this is processes communicating to external entities. Multiple processes communicate data to an entity. We don't have entity-to-entity data flow. That's not part of our system. It may happen, but we don't document that. And customers can't put data directly into data stores. Our system has a process to take information from a customer and put them into a data store. So processes are in between entities and data stores. And they don't have a specific name for this. It's just illegal connection. So if you're looking at a diagram and are being asked to show errors in it, you might call that illegal connection. If you find something back here, you might be asked to label the problem. You might call it a black hole data store or a spontaneous generation process, black hole process, gray hole. These are the harder ones to find because you have to actually look. Is the label on the data coming in allow the process to generate what's labeled on the data coming out? And sometimes the labels are very foggy, like customer information or student profile. And coming in, if it's only date of birth, that's probably not enough to generate a student profile. But if you have something more abstract like profile update, well, that's a lot of information probably implied in there. So gray holes are not going to be obvious all the time. Usually these are obvious. All you got to look for is only incoming data, only outgoing data. So having seen the basic rules, those are the 4 basic rules, the 4 entities. From there, we want to draw our context diagram. That's the first drawing we do. It's called a context diagram. And the context diagram has only one process. All it has in the middle is our system that we're going to build. In this case, a grading system, similar to our TIMS project. And here's how we show, here's an entity, is another system. Notice class roster is very abstract label for data. That's a valid label in our very high level context diagram. Here's how they start using numbers in that little label for your process. And we call this context 0 because this is our system. It's always 0, level 0. The external data, see how this is a very broad term, submitted work, graded work. At the context level, it's very broad terms on the data. And notice we don't put a double-headed arrow here. We don't say graded work or just work here. No, we show the system sends back to the student this information. They provide this information to the system. So very broad termed at the context diagram. So this is kind of describing in data flow diagram format, here's what our system does interacting with these external entities. Now I noticed a little video here. Let's see if this gives me a decent data flow example. This guy gives some advice about how to think about the different parts, and the general procedure is create a list of activities. At the level 0, it's okay, how does our system interact with who uses it? As you go lower in details, the list of activities gets more specific. But just think about the context level 0 at this point. Here's our naming guidelines. Let's see if they have it. External entities are always nouns. Data flow is always names of data. The process is always something that's being done, an action. And data stores are just the titles of what the data is that's being stored. So for a lemonade stand, we're not going to worry about use cases yet. That's coming up. But we think about, okay, what does a person do when they come to the magazine stand? Think about what happens. Here's the kind of things that are done at a lemonade stand. You request a drink. They serve it to you. You pay them. These things kind of, I would say, they give you the product after you've paid, and they're storing the product for other customers. So I'm not sure this is the actual sequence. Serve and produce, I'm a little confused what they mean. Let's see what he means by that. More activities to support those other activities. Group them in some logical fashion. Oh, so produce product is making the lemonade so I can serve it. Now here's our context level 0 for, oh, can't zoom in on that, for my lemonade stand. My customer, notice they're labeling multiple data as they get into the details. Generally, when we do our data flow or our context level diagram, we usually just have one data flow in, one out. I think this is a little busy for understanding. But they show that the customer gives an order to the system, they get their lemonade. And the order, I'd say, includes the payment. Here they've included multiple lines. The vendor goes and gets the lemonade, produces an order, and sends out goods. The system, the employee, does a lot of other things with the lemonade stand. I think this is a little more detailed context diagram. I'd probably simplify this for the example of a lemonade stand. Oh, as we get into more details, we'll be breaking up our system into higher levels of detail. So at 0, we're saying we're only showing the basic level of detail in our system. As we now think of what happens inside of our system, we'll be designing more processes to deal with what goes on inside. And then we'll be numbering those with sequential numbers as we go into increased detail. And there'll be examples of that. here's an example of going beyond the context diagram. Here's the context diagram. Now we go into, okay, inside of our system, we're going to break it up into multiple pieces here. And those multiple pieces we just sequentially number and give them a name as well. So we make a sale, we're producing, we're procuring materials to produce more product, and we're keeping track of payroll to pay our employees. This at the context level is all hidden inside the rounded rectangular number 0. So these are the details of what's inside our system. And as we come up with more details, we add numbers to that. Now inside of our context 1, see back here we have sale. Now we're going to jump into details of our sale process and see how it's labeled 1.0 here. As we go into the details of what happens in a sale, now we start labeling at the next level of detail, 1.1. We take the order, and notice customer order here. This should match a line coming in at the level above. See how customer order is coming in from a customer? Here, show it wrong direction. Here we show customer order is coming in to our process, and it goes to a specific sub-process called record order. Now, little error here, we're having missing labels here on our data flow lines. So there should be labels here, but you can see how we have a data store of customer information. We record the order, put it in the order data store. Then the process sees that an order is ready. They receive payment for it. They record payment into a payment data store. And see how the payment line, if I go back, there better be a payment line. Oh, how did I go back so far? There better be a payment line. Yes, there's a payment line here. Gotta be careful where I put my arrow. Actually takes me to a different slide. So there's the payment line coming in, and then the sales forecast is what's being sent out of this level 1 for process 1 that's been named here. So the data flow goes from very high level, although number 0, broad picture. As I get into more detail, I start numbering my additional sub-processes, and inside of a sub-process 1, after the decimal point, I add additional sub-processes in there. And if I realize record order needs more detail, I break that into smaller pieces. So now my level 2, that goes back to the second part, which was and there actually should be a name here calling this, as it was labeled up here, the production. 2 is the production process. Over here I should say, here, this somewhere this should say production process system. So in a dotted line around this should be production process. And inside the production process I have level 2 subparts. Is this making sense? And then at level 3 I'm going into detail of what happens in that circle 3 process. Notice this is using the alternative circle style instead of the rounded rectangle. But the same idea. We label them, give them a name, and notice inside the process is the name of what it does. I wish I could zoom in a little bit on that. So a pretty good example. This is the kind of thing we're going to be drawing, and we're not going to be doing these kind of drawings. This is what they call a process decomposition, just kind of showing you as I go into more detail from a level 0 into the low or higher amount of detail, multiple sub-processes. If I have a sub-process, it would be 1.1.1, 1.1.2 if I had more details to go into the record order process. Once all processes have been broken down into as specific detail as they can, that's called, I think they call that leveling out the process. And see if the book, I think the book may actually have some examples as well. So here they explain a grading system, or what is this? This is an order system. Here is the context diagram. The system is our order system. Broad terms on the data coming in and out. Here I don't really like multiple arrows in and out. It kind of makes it hard to read, but they're doing that here. I prefer the single line, and then as I get into the lower levels, maybe adding detail. This is showing that since there's a lot of interaction with the order, they just wanted to make multiple lines where they make the order. Sometimes they'll get a reject notice, otherwise they'll get an invoice, and then the customer gives payment to our system. I would probably say order includes the payment. Maybe it doesn't happen at the exact same time until they get a confirmation of the product is available or something. But I might have order and then invoice status. Instead of having two arrows, I might just say invoice status. And one possible status might be rejected or accepted. So in your context diagram, you want to include all the entities that might interact with your system. Now think of our TIMS system. What might we have for external entities interacting with our TIMS case study? Yeah, students are going to be coming. They're like our customer. They'll be interacting with our TIMS system, which will be a rectangular box, level 0. And this will just say TIMS. What other entities do we think of our system requirements? Yeah, so instructors, since they have a different kind of interaction with our system, we'll label them as a separate entity. Now someone might look at our system and say, wait a minute, teachers are just like any other user, but inside the system they have a different status. So we might wrap teachers and students and just call them users. And you often see that with operating systems, that anyone interacting with the system we label as a user. Depending on how your group wants to think about teachers and students, you may break them into two different entities, or you may treat them as one, and then inside the system you keep track of their role and status. As I've been learning the Moodle system, I'm finding that teachers and students are all treated like users, and inside the system they just have a different status. I can make a user any student. I can just say enroll them as a teacher into this class, and they're a teacher. They can be a student in another class. Question, Hannah?
I was just wondering if you have like administrators as different entities.
Yeah, because they have more different, lots of different defined roles and capabilities. So yeah, I might list them as separate. So students, teachers, administrators, and one more mentioned. I think it's mentioned maybe just once in the description of our TIM system. Actually, there's a couple more possibilities. They mentioned at some point that would be providing information to the accounting system for payment. And if I want to be able to interact automatically with the accounting system, I would put that as an external entity, like they have here the bank, or here they have accounting. Now, depending on if we weren't able to automate interaction with our accounting system, we might, instead of accounting system, make that the accountant. And they're responsible for exporting data from the system, and what they do with it, like import it into the accounting system, we don't have to worry about that. But if we're going to interact directly with the accounting system, in real life, that's going to require a little more specific details, but we'll treat that as a very specific entity that we need to interact with. You could. I might call them admin, but if they do enough different things that we need to kind of treat them as a different entity, yeah, you could call those backup operators or something, because they have a different role than your average admin. And that's up to the designer. As you discuss your system, how you're putting it together, it's not strict on what you could label. And that's where the discussion with the team is, okay, how are we going to define all the people or entities that work with our system? So two groups may come up, although the system may be the same, their context diagram may not be exactly the same. Just as long as they follow the rules, they're okay. Is this breaking any rules? No entities are connected directly to each other. It's hard to break any rules since all we have is a process in the middle. If we go down internally here, now we'll start thinking about what are the basic processes that happen inside of it, and that's the diagram 0. Let's take a look at the diagram 0 now for a grading system. This is the context diagram. They show a 0 on the rounded rectangle. Now we go to what they call the diagram 0, which is breaking out the basic processes that happen in a system, laying out as in general detail. And I don't know if there's rules about how many processes in the context. So they give specific rules. You're basically breaking out multiple processes, and they have come up with 3 processes. It's a slight expansion of process 0. In this example, they show 4 main internal processes. And let's see if they mention anything about how many main internal processes you're allowed. They don't say specifically. But here's your context 0 diagram. And in the grading system example, here they show a system, external entity, a student, and an instructor. In ours, this is we can kind of use this as an example of build on something like this for our TIM system. Here is now the context, or the diagram 0, which is kind of blowing up that middle rectangle. See, the same external entities are listed, but being more specific in pieces of the system that the same external entities are interacting with. So at diagram 0, you need to keep your external entities, but you kind of blow up that middle system. And I'd say probably not more than 4 main internal processes. If your system is more complex than that, you might, you're going to need a bigger chart, but you might consider, let's categorize them and group 2 into one main thing, and on a further detail show those additional processes. And I don't know if there's one rule about showing one data store there. I don't think that's a rule. This particular one, they have the gradebook as their only data store shown on the context, or on the diagram 0. Now, other data stores may be used by the system. They are hiding inside these other processes. There can be more data stores. This is just showing that in our first diagram 0, we're envisioning one main data store that's a main thing being used by a lot of systems, so let's show it here, is our gradebook. Another data store might be your, that you could show at this level, might be your list of users, because you have them throughout. This, in the terms of the system, represents probably a table in a database. Now, just for fun here, before we finish up here, let's take a look at, see if I can get you here, if you still have this. this is what's being used in our system. These are the databases being used in our eLearn system. It's running the Moodle software, and I have many backups of there. I should probably be cleaning up some of these backups. But our latest eLearn 2 system has this database. We're on version 2.7 on the eLearn 2 system. Your elearn.emmaus.edu is using a Moodle version 2.8. But inside of this, there's our data store. Look at all the tables being used inside of there. This is one database, one system. I didn't count them all, but let's see if we have a. Here's a. Do we even have a grade book? Let's see. We have grade categories, grade reports. So the grade book isn't just one table in a database. In our diagram 0, though, we might just call it grading. But actually, in our system, look at how many tables they've broken up gradings into. They've got forms and they've got grades. Because of the many ways of treating grades, rubrics and outcomes and letter grades, there's gobs of little tables inside the actual system. And this is why having some good database background, we didn't go into a whole lot of details with databases. As you work with a system and actually programming it, then you really get to know the nitty-gritty details of all those data stores. Now, if they had actually done a data flow diagram of this Moodle system, you would be breaking down many sub-processes into little data flows as we deal with all these little tables. At some level, if we're doing a complete data flow diagram, each one of these little tables would be a data store at some low-level system diagram. And as they add more features, there's tables to go with each one of those features. So a very complex system, open source with pretty impressive capabilities, but built up by multiple people over multiple versions. I'm not sure if they actually have any kind of data flow diagrams. It'd be interesting to see how they document how for developers, how in the world do you work with this system. Each of these tables has specific sub items within it. Let's say we're doing let's look at one of them, how about grade items. Lots of items within each table. It can get very complex. And the data flow diagram helps you to kind of, at the logical level, show, okay, that table's got a lot of crazy things in it, but here's the general flow of data for why we have that table. Now, a big danger of all this is, does this documentation actually match what you're doing? That's the big problem with flowcharts too. You lay out your plan, later on you change what's happening, you never come back to the main data flow diagram to show, we're actually not doing it that way. We thought it was going to happen this way. It didn't really happen this way. That's just what happens with systems. Since there's not a direct, this doesn't generate my code or my databases, there's not going to be a synchronizing necessarily unless you have people that are careful to make your diagrams go with how you're actually programming your system, just to keep everyone understanding your system. So a challenge for someone would be, look at a system, verify, do our data flow documents that we started with, do they match what we're actually doing today? That would be a job for someone that would have to understand the code, understand data flow diagrams, and help to just train other people coming in to understand their system. And this is why adding another person to the system doesn't necessarily mean you get more done, because they have to learn all of this, and this all has to be made sure it's correct so that person coming in knows, from this can tell actually how the system's working. So there's a quick intro to data flow diagrams. We'll be doing more then. Look at the case study. I think assignment is to be building our diagram 0 for our TIM system, which we'll work on next time.